Do we remember the formula for hyperbola?
Isn't it same as ellipse, but there's a minus?
That is correct. So everything is the same except for one of them will be subtraction. So in this case, we do have to watch the order just because people like to have the subtraction in the middle. So x minus h squared minus. What you drinking there, Madeline?
What?
What you getting to drink?
Coffee?
I want some coffee. Can I have some?
Sorry.
Alright, so equations are pretty much the same, difference being the subtraction one. Madeline, that was your hint to mute.
I'm trying, I promise.
The only difference being that one of them is subtraction. The important thing to note, though, here is that the a value and b value do not switch variables. A is still under x and b is still under y. Okay. What about our c value for hyperbolas?
Isn't it still the same thing? Or like c squared equals a squared minus b squared, or b squared minus a squared? Isn't
Am I the only person that Harrison's robot-y for?
Yeah, I don't hear.
Okay. You want to check your internet and
or is
disconnect and
it
reconnect,
different?
Harrison? Sounds like you're having issues with your internet, buddy. But he was saying that it's the same as the ellipse, so a squared minus b squared or b squared minus a squared, depending on which one's bigger.
How about now?
That's much better, buddy.
Alright, thanks.
Do we agree with Harrison? It's the same as the ellipse. Anybody? Somebody?
I
What
swear,
was the question?
all these things ever are is just awkward silences because no one ever talks.
Yeah, it's a little strange, but it's the best we got for now. I mean, it's kind of the same thing as class, so nobody wanted to answer there either. So the question was to find our c value. Harrison's saying it's the same thing as an ellipse, so a squared minus b squared, or b squared minus a squared, depending on which one it is. Is that correct?
Yeah, I agree.
Yeah.
And that would be wrong. It'll be, for hyperbola, it is basically the same thing as the Pythagorean theorem. And before anybody asks, no, it is not the Pythagorean theorem. It is just the same relationship. But it is a squared plus b squared equals c squared. So in this case, it doesn't matter what kind of hyperbola you have. If it is a upwards facing parabola, or up and down, or left and right, it'll still be a squared plus b squared. So that part does not matter. Everything else for the most part is the same. So the center, the vertices, the foci, they're all the same. However, we have to also remember that your you have asymptotes. Sorry, brain fart for a second. You do have asymptotes for hyperbola, which we can't forget. So our asymptotes are the same for both, which is really nice. So y minus k is equal to b over a, right? Yes. X minus h, plus or minus. So we can't forget that we have to write those equations as asymptotes in a lot of cases. Remember, I showed you some easy ways to get them as far as when you're graphing them, and we'll go back over that again today. Okay. And then eccentricity is the same thing. It's your C value over your A or B, whichever one is your dominant one. Okay. Any questions as far as that goes with the basics before we start doing some problems?
Hyperboles are very similar to the last lesson, aren't they?
They are extremely similar, yes. That is the problem with this section of like this unit or whatever you want to call it, is that they are very similar. So keeping them distinct and knowing which part is which can be difficult if you're not careful, and you can mix them up. In of themselves, like each individual problem is not very hard, but you got to know which one it is. Is it a hyperbola or is it an ellipse? How do I find my C value? Did I do my C value correctly? Because if not, you're throwing things off. So I try to kind of make it as easy as possible. Okay. So when we talk about this, we have to remember, in our case, it is determined by the leading one, the positive one, if it is horizontal or vertical. So if x is positive, it's horizontal. And if y is positive, then that one's vertical. So that tells you which way your, I call them double parabolas, which way your parabolas go. So they either go up and down or they go left and right. The formula on the bottom is for your asymptotes. Okay. And I'll just do problems from the homework, that way you guys can have it done instead of both problems. Any questions before I start problems on any of the pieces, where they kind of go or what they are? Okay. All right, so all right, we'll do number 11. So if you're following along in the book or want to do some homework problems, this is number 11. So number 11 gives us the foci, r0 plus or minus 3, and the conjugate axis, which I didn't mention earlier because I forgot. Length equals 2, if I remember correctly. Okay. Yes. Okay, so before I forget to mention it again. So conjugate axis. Remember on an ellipse we had our major axis and minor axis? The major axis was always the longer one, the minor axis was always the shorter one, so it's pretty easy to tell. Instead of that, because you don't know which one's bigger on the hyperbolas, because either one could be bigger, it depends on which way it opens. So conjugate axis will be the basically the same thing as the minor axis, is how I think about it. So this is like the minor axis from the ellipse.
Am I the only one who can't hear him?
Okay,
Yeah, I can't hear him
Yeah, I
either.
can't hear him at all. Okay, I was worried that was
O'Donnell.
O'Donnell. You died, bro.
Hello.
Can you hear me now?
Yes.
Yeah.
Yes.
Sorry about that. I don't know, apparently my headset cut out. I'm sorry. When did I cut out?
20 seconds
When you're
ago.
talking about the conjugate.
Okay, so sorry.
Yeah.
Yeah, if something happens with the sound, do message something in Discord or whatever, because That's why luckily I was coming back to check to see who was going to be talking when I asked the question. So your conjugate axis is very similar to your minor axis from your ellipse. The problem is we don't have a big and a small with hyperbolas. Either one can be big or small. So when we talk about conjugate axis, it's the one that's not the way that it opens. So it's easier to show this with an example. So if we look at ours, for instance, we have our foci at 0, 3, and 0, negative 3. So which way does this hyperbola open?
Horizontal.
So horizontally, correct. So left and right, which means that if horizontal would be the major axis, if it was an ellipse, that means the minor axis would be vertical. So that tells me that my conjugate axis goes vertically up and down and has a length of 2. Does that make sense?
So how would it go up and down if basically there's nothing there?
Don't forget, remember when we graph it, we had that box when I did it in class. Remember the box that I made?
Yeah.
Oh,
So that conjugate axis is used to make the box for our asymptotes and things like that. Okay. So if we have foci at 0, 3, and 0, negative 3, what information does that help us get?
I don't think
the
it's called the
center.
center. I don't know if it's called the center or not, but
It's still called the center, yes.
okay.
Yeah, we still call HK the center. That didn't change. I mean, at least I call it the center anyway. Let's see if the book does real quick. I'm pretty sure they still call it the center. Yeah, they still call it the center too. So that gives us our center. So what is our center value?
0, 0.
So very easily we have a center at 0, 0. Okay. What else information or what other pieces of information do we know?
The box.
All I heard was the box from you, Miss Abby. Okay, so let's look over
Can't you figure out your asymptote somehow?
not yet, no. Because what do we need for our asymptotes? We need H and K, which we do have, okay. We also need A and B. Do we have
Oh,
A
yeah.
and B?
No.
No. So far we got the center from our foci, which is good. Why did they give us the conjugate axis length? What is that going to give me?
The box?
It helps me with the box, yes, but what is that value for? Remember, what did we use our minor axis length for in an ellipse?
Was it either A or B?
Correct.
Like depending on if it was vertical or horizontal.
Correct. So your conjugate axis, your minor axis from an ellipse, will help you get either your A value or your B value, depending on which one it is. Which way does our conjugate axis go on this hyperbola?
Vertical, so it's Y.
So what value does that give me? Is that A or B?
B.
B.
Very good. So remember that length, though, is 2 of them, so we know that 2B equals 2, so B equals 1. So we now have our B value. So we're getting there. We can now almost write our asymptotes. Now we just need our A value somehow. Well, the minor axis, or the conjugate axis in this term, doesn't do anything else other than find that B value for me. So that means I'm missing some other piece of information somewhere that they've given to me that they've hidden in the problem. And it has to do with the foci. So what else besides finding the center can we use with the foci?
You find C.
Correct. We can't forget that your C value is determined for your foci. Either you can get it from the foci or it's used to find the foci. So in our case, our C value, so we know 2C would be equal to 6. So C equals 3. Does everybody see how I got that?
Yeah.
I don't understand how you got that.
Okay, so what's the distance between the two foci, Brisa?
6 units.
Okay. And we know C is the value from the center to one of the foci. So from foci to foci would be 2C, just like with our conjugate axis, that's the whole length. So that's 2B values.
Okay.
Okay. So now we can find A with that using our formula that we looked at before. So we know C squared is equal to A squared plus B squared. So plug those in, you get 9 is equal to A squared plus 1. So A squared is equal to 8. And as a reminder, unless we're trying to find everything, if we're only trying to, in this case, just write the equation, I don't need to find the actual A value. That's not going to be necessary. I just need A squared. Okay, so now we have enough information to write our formula because all we need is the HK, A, and B values, and we can write our formula. So we get, which one's going to go first, X or Y?
Is it X because A is bigger than B?
Not correct.
Hmm.
Okay, so I will give a hint. Madeline was half correct. X does go first, but not because A is bigger.
Is it because on the foci the Y is the one that's changing? Or sorry, yeah. No. Never mind. Sorry.
You know, nobody caught what I did.
Yeah, I just caught it.
You did, and you made me catch it.
Yeah.
It was the Y was up and down.
The whole thing is supposed to be going up and down, not left and right.
It is. I was not paying attention.
Does that mess up the whole problem? Do we have to start all over?
No. It'll just mess.
Okay.
It'll switch A and B is all it's going to do. So that means this is 2A, and then this would be B. So it's just minor adjustments, but I can't believe I did that, and can't believe nobody else caught it. So A is 1. So then B squared. Okay, so now which one goes first?
Is it X?
No, now it's not X. Remember, the way that we
Wow.
write the equation is determined on which way it opens. Which way does this hyperbola open if the foci are vertical?
Up and down.
It opens up and down, which means my first variable has to be y. So it'll be y minus 0 squared. B always goes with y. Make sure you understand B will always go with y. So B squared is 8 minus x minus 0 squared over 1 squared. And the answer, remember, in hyperbolas and ellipses, it will always be equal to 1. Okay, any questions?
Wait, so A equals 1 and
B squared equals 8. You never actually need to find the B value because all we're doing is writing the equation. We're not actually graphing it. Okay, any other questions? And apologies for the mistake. Thank you, Miss Madeline, for catching it. Okay, so good with that
So
one.
if there's you might answer this later, but what's so like there's a major for the ellipse, so what's like the major for hyperbola?
It's called a transverse axis. So the minor is
Okay.
called conjugate, the major is called transverse.
Wait, why does the Y come first?
Because it opens up and down. the direction of which it opens will determine your positive variable. So if it opens up and down, then y is positive. If it opens left and right, x will be positive. Okay. Any other questions on that one? All right, I will leave the rest of that section. There's only 3 other problems, kind of given the same information there, and we'll look at doing one where we complete the square again. So, does anybody have the book open?
What?
Ask me if anybody had the book open so they could read me the problem, or if I had to just memorize it. 9 squared. Okay, so I'll be looking at number, I think it was 19. So it's 9y squared minus x squared. Um, 54y 4x 68.
What question is this?
19. If I copied it correctly. 9y squared minus x squared plus 54y plus 4x, yes. Okay, so they want us to basically write the equation in standard form and then identify all the important pieces and then sketch the graph. All right, so what is my first step going to be? Let's call on Brandon.
Don't you complete the square?
Okay, what do I have to do before completing the square though?
What you call it? Yeah, like group them together. Factor.
Reading Calvin's answers. So remember, in order to complete the square,
No,
what?
I'm on the stream. Oh.
You're okay, buddy. So we have to factor because we cannot leave that 9 in front of the y squared. So we'll kind of do a combination of what Brandon's put together as the first step. So when we do that, before we can complete the square, we need to regroup them, so that is correct. And we also need to get that 9 out from in front of the y squared because we cannot complete a square. At the same time, we also are going to move this 68 over. So you'll get 9y squared plus 54y minus x squared plus 4x equals negative 68. And then I'm going to go ahead and factor out the 9. So I get y squared plus 6y. And this is where I'll put my blanks in.
Do you have to factor out a -1 on the x squared?
Yes, good. I was just getting ready to ask that. So you do have to be careful and remember to do that. Otherwise, you will not get the right answer. Plus blank, plus blank. Okay. So it has to be a positive 1 in front of our variables, so we do have to factor out that -1 over there. So that will change that positive 4x into a negative 4x. Okay. Who do I want to call on? Sydney, what goes in the first blank? You've unmuted yourself, but you're not talking. You can type the answer then, and we can get your voice figured out later if you want. Nine is correct. So remember we cut that 6 in half, square it, and we get 9. Jason, what goes in the second blank? Four is correct. So half of -4 is -2. We square it, we get 4.
Wait, does y have to go first?
Yes.
Or okay.
Why does y have to go first? Somebody answer that question for us.
Because it's positive.
Very good. So technically it doesn't have to go first, quote unquote, but yes, it will need to go first because it's positive, because that's how we want to see things, and that's how we can identify everything. Let's see, third blank. Let's ask, I haven't picked on Gretel in a while. Gretel, what's the third blank?
I could be wrong. But don't you just put. Wait a minute. Is it just 9 and 4 again?
It will not be 9 and 4 again.
Oh. You square them? 81?
You don't square them. In this case, it ends up being squared, but remember, we're not putting in just 9. We have this 9 out in front of the parentheses, so I've actually added 81.
Oh! Yeah, okay, yeah. There we go.
And then Miss Dela, because I haven't picked on you in a while either. What goes into the last blank? Ooh, very good. That was a tricky one. So you got to be careful. Don't forget this negative does distribute to that 4 as well. So -4. Good job catching that. Okay, at that point we can go ahead and do our factoring and simplifying on this side over here. So we get 9. Hopefully everybody remembers this will factor into 9 plus 3 squared, and that will be x minus 2 squared. Was that 72? So equals 9. All right, JDev, what do I do now?
Put it in the form.
How would I accomplish that?
Don't you know the center?
We do know the center, but right now we're still trying to get it into standard form. We're not quite there yet. We have one more step.
Don't you have to divide by 9?
Why is that, Mr. Harrison?
Like divide that because you need to get the other side to 1. Because it all has to equal 1.
Okay, so that is correct. We have to have this equal to 1, so we're going to divide everything by whatever number is on the right-hand side. By, and that turns into 1. So we get y plus 3 over 1, technically, minus x minus 2 squared over 9 equals 1. Okay. Any questions on that entire process of getting it to standard form?
So whenever there's like a 9 on top and the 9 on bottom, the denominators.
Yes, it will simplify. So you simplify it to whatever it simplifies to. It just ended up being this case that 9 over 9 simplified to 1. So, and we need something on the bottom there so that we know what the a and b values and stuff like that are. Yes, Kelvin. The only difference between the hyperbola and the ellipse is the sign in the middle of them. So one of them will be negative on an ellipse, and one of them will, both of them will be positive. Or sorry, one of them will be negative on a hyperbola. Both of them will be positive on the ellipse. And that's how you tell which one it is. So as soon as this problem is written out, as soon as you see that negative in front of the x squared, that automatically triggers that it's going to be a hyperbola versus a ellipse. Okay, so now at this point we should be able to pretty much identify all the important information. So let's see. I don't think I caught on Brisa. Brisa, what is the a value?
Isn't it 9? No.
So how do we find our A value?
A
Well,
squared is
Wait,
always
it's
under the x.
wait,
that's
it's 3.
So there you go. So it won't be 9. Remember, that's our squared value. So A is 3.
3.
So, and good job on pointing that out, Madeline. So the A value will always be with the x. What about our B value? So most of this should be pretty easy, so I don't think I need to call on people. So what's our B value?
it's 1.
So B always comes from y, same thing, take the square root. So B will be equal to 1. What about our center? Should be relatively easy.
Two negative 3.
Ooh, good job. Don't forget, it always goes HK, so always put the x value first, and then the y value. Okay.
Can you go over how to graph this?
Yeah, I'm getting ready to graph. As soon as we get all the information, I'm going to erase the equation. I'm just making sure everybody has time to write that stuff down. Let's see. Do we need anything else to graph? Oh, foci. We need our foci. How do we get our foci?
Using C.
Okay, so how do I get C then, Mr. Harrison, since you volunteered?
Same thing as Pythagorean theorem type thing. It's C squared equals 10, so it's going to be the square root of 10.
So very good. So C squared is equal to A squared plus B squared. So C squared is equal to 9 plus 1. So C is equal to square root of 10. Not a very pretty number, but we're only going to be sketching a graph. We're not doing an exact graph, so it's okay. Asymptotes, we can go ahead and write our asymptotes. I'm going to have to start erasing some of this. Is everybody okay with me erasing the equation? Anybody still need it up? Okay, I'm going to leave the bottom one though, so I kind of need that stuff right now. Okay. So for our asymptotes, we have a nice easy equation. So y minus k, since we haven't done this, I'll go ahead and walk us through this one. So our k value being negative 3, so y plus 3 is equal to plus or minus. Don't forget it's b over a every time, so 1/3. And then x minus 2. Okay, so those are our asymptotes. Oh, sure, is there anything else? Oh, eccentricity. And then we need our eccentricity value. This won't help us with the graph, but they will possibly ask us for it. So how do we find our eccentricity value? Anybody remember that formula?
Wouldn't it be, isn't it C over, or is it, wouldn't it be C over 3? Or am I, it's C
Yeah,
over
either
something.
C over A or C over B. I don't know which one.
Yeah,
Okay, so
it's
that,
the higher one, right?
no, only the ellipse was the higher one because that was the major axis. On a hyperbola, which one is our quote-unquote major axis?
The one that's going the same way as it opens.
Correct. So in our
You're
case, it's very easy. It will always be over the positive one. So in this case, it'll always be, in our case, it'll be over 1 because our b value is 1. So in our case, it's c over b in this case, which is equal to, c was square root of 10 over 1.
So it's just the square root of 10.
Yeah, just square root of 10. If you want to simplify it, leaving it like that's perfectly fine as well. Okay. I think that's all the information we need. We should be able to graph it from there. Yeah. Okay, so I can go ahead and get rid of... Oh, we actually need the equation of our foci, or the points of our foci. So remember, foci are coordinates, so we need 2 of them. So how do we find our foci in this case? Okay, so first question with that is, where are the foci always located?
The center is in the middle of them. I know that.
The center is in the middle of them. So remember, on an ellipse, where were the foci located?
On the major axis.
On the major axis. So where are they going to continue to be on a hyperbola?
On the major axis.
On the major, but instead of calling it major, we call it now, make sure we have our terminology, we call it the
Transverse.
transverse. So in other words, which one's our transverse axis?
The Y,
The big
right?
one.
Careful, not the big one. This is where we got to be careful. It's the positive one. So our transverse axis will be the up and down.
The Y-axis.
The y-axis, correct. So that means our x value is not going to change at all. The y value will change. So remember, our foci are going to be both up and down from our y value. So I'm going to have -3 plus root 10 and -3 minus root 10. And before anybody asks, yes, you leave it just like that.
Ew.
Yeah, they don't always look pretty. All right. So I think that is now everything, and we can now graph. Make sure I can graph points correctly this time. So our center is at 2, -3, so somewhere right about there. Oh, we didn't do our vertices. Did it ask for vertices? Probably did. Yep. So how do we find our vertices? Because those are going to be very important. So this will be our center. We also need our vertices. So how do we find our vertices? Anybody remember that one? How did we find our vertices on an ellipse?
That's a no.
That's a no. So
Didn't we see like H and then K plus or minus C, or H plus or minus C K?
that is for the foci.
Oh.
So remember, the vertices are going to use your A or B value. So we'll use A or B in this case.
Would you use the B?
We will use B because that is the one that is with our positive. So that our vertices are going to be directly above and below our center, and we use our B value. So since our B value is 1, we're going to go up 1. I'll do it in blue. So where was that? -2, -3, so that's -3, it's -2, and -4. So our vertices will be a little bit above and below. And then our foci will be inside of our hyperbola. So if I do -3 plus square root of 10, that's a little bit positive. Not exactly 1, but a little bit above there. So about 2, so. And the other one will be right about there. And you would use your calculator to get a decimal approximation for that. So it's a little after -6, in case you don't know. Okay. Then at that point, we make our box, if we remember from before. So we know our A value is 3. So I'm going to get rid of my center point now. So 1, 2, 3. And then about there. So I probably need to go a little further. About there. So I went to the right and left my A value, which was 3, and made the green dots, which would be a lot of people, like I talked about, remember I call those our minor vertices. That's what I would call those. And now we get to make our box. Oop, too far. Not the red. remember to get your asymptotes, you just draw from corner to corner. I'll do them in blue. Oh god, it's gonna be bad. Almost went through the center. Obviously, you'll have actual graphs to do this on. And then what's the one last very important part that I told you guys about hyperbolas when drawing the graph? Does anybody remember? It must touch your vertex. So I would start from the vertex and curve out and go close to your asymptotes. Any questions?
No.
How would you know how wide the box would be?
You go your A and B values. So remember, in our case, since it opens up, there's B is half of it up, and as we go to the sides, that's an A value. So whatever, it's dependent upon your A and B value. So to get your points, you would start at your center, go left and right your A value, in our case, which is 3, and go up and down your B value, which is 1. So it'll be dependent upon your A and B values.
Just a quick thing. The vertices are the ones that are closer to the center, the ones that they all branch off of, right?
In this case, yes. So your vertices, since we know it opens up and down, I didn't put the answers in there, my bad.
How would you find them again?
So in this case, since it opens up and down, since y is positive, it'll be your b value up and down from your center. So since our b value is 1, our center is there, so it should be at 2, -4, and 2, -2. So you go up and down your b value, since this one opens vertically. If it was horizontal, you'd move left and right.
All right, thanks.
Mm-hmm. All right, any other questions?
Do we still have to do homework, right?
Yes, you still definitely need to be doing your homework.
All right. I just needed.
I don't know exactly, again, what it's going to be due as far as for a grade or anything like that, but I will definitely say that if you're not doing your homework, you're going to not do very well in these tests. For instance, if you couldn't do this one without a problem, you definitely need to be practicing these. All the problems, for the most part, are the same, but it's the fine details that are going to be different between like the ellipse and the hyperbola and stuff like that. So you definitely just want to make sure you're practicing them. And no, Mr. Kelvin, you don't have actual class unless you want to come ask questions. I can make myself available for questions and get in Discord and do stuff if you need, but no formal class tomorrow. And as a reminder, the streams are being posted on YouTube. I sent you the link for the YouTube channel yesterday, I think, didn't I? Could someone confirm I did send that link out yet?